Next up, we're just going to practice using these formulas we just learned. So we're going to find unit tangent and principal unit normal vectors for the vector function given by r of t with two components, 3 sine t in the x component, 4t in the y component. Sorry, it has 3 components, 3 cosine t in the z component. Remember, we can always write that 3 sine t I hat plus 4t j hat plus 3 cosine t k hat if that's what we prefer. So if I'm looking for tangent vectors, I know I'm going to have to take my derivative. So in the first component, the derivative of sine should become cosine. My 3 stays out front, and I don't end up with an extra negative. In the y component, the derivative of 4 times t with respect to t should just be 4. And in the z component, I know that cosine t, when you take a derivative, becomes sine t, but it does throw that negative sign out front. And then if I'm asked for my unit tangent, I know that I'm going to need to be able to divide out by the magnitude of r prime of t. I could be going back to my formula that I wrote down on paper, or I could just say r prime of t tells me tangent. They told me unit. I get rid of magnitude, whatever works for you. We just go back to our formula. We know that that's given by 3 cosine t squared plus 4 squared plus minus 3 sine t squared, all under a square root. That gives us the square root of 16. Well, I'll keep it all in order for now. 9 cosine squared t plus 16 plus 9 sine squared t. And then remember that cosine squared plus sine squared is 1. So this whole thing right here is going to just be 9 altogether. I think you all would have used a rule similar to that in web work recently. So that's just square root 9 plus 16, square root 25, that's just 5. If this jump right here kind of freaked you out, give us a pause right now, think through those algebra trig tricks, and it should connect with you. But then going back to our formula, we know that that unit tangent vector is r prime of t divided by its magnitude. So we're going to have 3 cosine t 4 minus 3 sine t, all divided by 5. And that passes into every component. So we're actually just looking at 3/5 cosine t, 4/5, and minus 3/5 sine t. And that would be the first part asked of us right here. Oh, that's not a good box. For the unit tangent vector. There we go. Kind of. The second part is to get the principal unit normal vector. And so again, I would say I'm going to have to take a derivative of this. So derivative of cosine, we know becomes a sine, pulling a negative out front. Derivative of a constant number with respect to t just becomes 0. And then derivative of sine becomes cosine, and it doesn't change the sign at all, so that negative that was already there sticks around. And then because it's a unit vector, I know that I'm going to have to get rid of the magnitude. Oops. So let's see, that's going to be the square root again of each component squared, minus 3/5 sine t squared plus 0 squared plus minus 3/5 cosine t squared. That's going to become square root 9/25 sine squared t plus 0 plus 9/25 cosine squared t. Using the same reasoning as before, sine squared plus cosine squared becomes 1. This just becomes square root 9/25, or just 3/5. And so that principal unit normal vector n of t, given by our formula, t prime of t over magnitude t prime of t, that's going to be minus 3/5 sine t, 0 minus 3/5 cosine t, all divided by 3/5. So when you divide 3/5 by 3/5, that's just going to cancel out, and you're left with minus sine t. 0 divided by any number is still 0, and then the 3/5 cancel out, minus cosine t. Oops. Okay. That is so not working for me today. That's okay. That's a box. And our first one, it might not have been obvious to you that this is a unit vector, but hopefully it's obvious to you that this one is. If you start to compute the magnitude, you're going to get sine squared plus cosine squared. That's one. We've used that so much this problem. Whole length is one. And that's the process for this type of problem.